Let's consider several problems in number theory. And consider the following problem. Suppose a is not divisible by 2, so a is odd. What possible remainders can a have when we divide it by 4? Okay, so there are 4 possible remainders for the number when we divide it by 4. The remainder can be 0, it can be 1, it can be 2, and it can be 3. So let's consider these cases and see which of them are possible. Okay, clearly the remainder 0 is impossible. If the remainder is 0, it means that a is divisible by 4. So it has the form 4 times some integer k. And so a is even. So, but we know that a is odd, so this case is impossible. Okay, there is one more similar case. Consider the remainder 2. So suppose a has remainder 2 when we divide it by 4, so a has the form 4 times some q plus 2. Note that here a is also even. Note that 4 times q is even and 2 is also even, so the sum of these numbers is also divisible by 2. So this is also impossible since we know that a is not divisible by 2. There are 2 remainders left, 1 and 3, and they are both possible. So clearly, so here are simple examples. A is equal to 1, and then if we try to divide 1 by 4, then clearly the remainder is 1, and a is equal to 3 is another example. If we try to divide 3 by 4, the remainder, then the remainder will be 3. So the remainders 1 and 3 are possible, and the remainders 0 and 2 are impossible. Let's consider the following problem. So suppose we have 4 integers, a, b, c, and d. Can we say that 2 of them must have a difference that is divisible by 3? Can we say that for any 4 integers there are 2 among them such that their difference is divisible by 3? Okay, let's consider some examples. Let's just pick some numbers and see whether this is true or not. Let's pick number 1, 100, 27, and for example 5. Okay, let's look at these numbers. Can we find 2 of them that has difference that is divisible by 3? And indeed we can, if we subtract 1 from 100, then we have 99, which is divisible by 3. 99 is 3 times 33. We failed. We tried to find an example and we failed. So probably we should try to show that it is always the case. And indeed this is true. It turns out that this is always the case. Among any 4 numbers there are 2 such that their difference is divisible by 3. Why is it so? And the crucial idea here is the following. Just note that there are only 3 possible remainders when we try to divide numbers by 3. The remainders are 0, 1, and 2. And we have 4 numbers. So note that among these 4 numbers, at least 2 must have the same remainder when we try to divide them by 4. And so if we subtract these 2 numbers, as we already observed, the difference is divisible by 3. If 2 numbers have the same remainder when we try to divide them by 3, then their difference is divisible by 3. So it is always the case. Among any 4 numbers there are 2 such that their difference is divisible by 3. Let's consider the next problem. Consider 3-digit non-negative numbers, and the question is the following. Suppose we are trying to divide them by 101. How many of the numbers will have the remainder 7 if we divide them by 101? And here in this problem we assume that 1-digit numbers and 2-digit numbers are also 3-digit numbers. We just start with zeros. So 3-digit numbers are numbers from 0 to 999. Okay, let's see how many numbers do we have in this problem. Let's look at all numbers that has remainder 7 when we try to divide them by 101. And all of them has the following form. A is equal to 7 plus q times 101. And q here is arbitrary integer number. Okay, let's look at all possible q, values of q, and see whether they fall in our interval, whether the result is between 0 and 999. Note that if q is negative, then a is clearly also negative, so these numbers doesn't fall in our interval. Now, the first number that falls in our range is for q equals 0. Then a is equal to 7 plus 0 times 101, which is just 7. So for q equal to 0, a satisfies our property. Okay, now we have q, the remaining q values of q are 1, 2, 3, and so on. And the number a grows when q grows. And the last q, such that a is still a 3-digit number, it is not hard to check that with q is equal to 9, then a is equal to 7 plus 9 times 101, which is just 7 plus 909, which is 916. The next a will be already greater than 1000. So this is the last q for which our number falls into this interval. So a falls in our interval, a is 3-digit, for q from 0 to 9. There are 10 such numbers q, so there are 10 such numbers, so there are 10 3-digit numbers that give remainder 7 when we try to divide them by 101.